How do we integrate the fourth power of tan x? I received a comment asking me to integrate this, so let's have a look. We already integrated the fourth power of secant in a previous video, and back then the strategy was to decompose it into a product of two squares and then use the property relating tan squared to secant squared. If we try replacing one of the copies of tan squared with this, let's see if there's a substitution we can use. For example, u equals secant x would give us du equals secant tangent. But we have tan squared outside the brackets, so that won't help. How about something else? For example, u equals tan x. Du would be secant squared x dx. Now we have secant squared x minus 1. So once more, this is not going to help. Let's try something else entirely. How about replacing both copies of the squared tan with secant squared minus 1? In that case, we'll have secant squared x minus 1 all squared. Expanding, we get the fourth power of secant minus 2 secant squared plus 1. Now, the second and third term are easy to integrate. The integral of secant squared is just tan x, and the integral of 1 is of course x. So we only have the fourth power of secant to integrate here. But this is precisely what we integrated in a previous video. The strategy was to decompose it into secant squared times secant squared, and then invoke that same property on one of the copies. With a simple substitution u equals tan x, it's very easy to see why the result is the following. If you'd like to see a more relaxed explanation, feel free to go back to the video of the integral of secant to the 4. If we replace the integral with this result, we'll see that we have tan x minus 2 tan x, so we can combine them into negative tan x. And that's it. This is the result. The integral of the fourth power of tan x is 1/3 tan x cubed minus tan x plus an arbitrary constant of integration. If you have any integral suggestions, make sure to leave them in the comments down below. And last but not least, congratulations to the challenge question winners from my previous calculus video on the soda can optimization.